Hello everyone, we're going to do the 2022 physics exam today. I just sat my methods 1. It was alright. I realized when I got home though that I somehow got the last question wrong because I somehow was off by a factor of 10. I must have just forgot a digit or something, because you were supposed to get like 500 years, but I only ended up getting like 50 something years, so pretty disappointed about that. But it is what it is, just gotta move on. So I think definitely subject exhibition doubt. People have been getting hundreds for like the past 3 years. And then I'm not sure about subject excellence, because that might be 1 or 2 marks lost, and I probably lost, well, with how I was doing with my past WACE exams, I've been losing a few marks here and there, especially in calculator soon. So, well, that's alright. Not getting my hopes too high, but let's do this exam. We got 48 pages. Looks like quite. Let's see. Ooh, 40 pages to do. All right. Let's get started. So now we're starting now. Light has a wavelength of that and is shown onto a photoelectric. Calculate the maximum speed the electrons emitted by the plate. So let's find the energy of this photon. It's going to be hc over lambda. So 6.63 times 10 to the negative 34 times 3 times 10 to the power of 8 over 341 times 10 to the negative 9 . 341 times 10 to the negative 9. So this is 5.83 times 10 to the negative 19 joules, which is the same as times 1.6, divided by 1.6 divided by 10 to the negative 19, 3.64 electron volts. So then we can say that EK of the electron is going to be equal to 3.64 minus, the work function is 2.3, so we have 2.3, this would be 1.34 electron volts. So that's going to equal 1.34 times 10, 1.6 times 10 to the negative 19, 2.144. 10 to the negative 19 joules. Oh, really? I should have made this into joules, because I need like kinetic energy being joules, but yeah, whatever. So we know that this is going to be half of 9.11 times 10, negative 31 times v squared. So then v is going to be the square root of 2 times 2.144 times 10 to the negative 19. 1.11 times 10 to the negative 31, 2.144 is 10 negative 31. So I get 6.86 times 10 power 5 meters per second. Okay, Patrick and Dakish are sitting on a seesaw discussing physics. They decide to place the uniform 1 or 15 kilogram beam on the pivot as shown in the diagram below. Estimate that the system is balanced and tell us to lift his feet off the ground. Dakish is correct, and the system is balanced and neither of them touching the ground. Dakish has a mass of 60 kilograms. What is Patrick's mass? So we don't know the reaction force of here, so let's take moments around P. P, and we know that the sum of the anti-clockwise is going to equal the sum of the clockwise. Now Patrick's going to have some force going down. There's also going to be some force. How long is this beam? So it's going to be some force from the beam here, and then Dash the fatty is going to have some force going down here as well. So anti-clockwise is only going to be Patrick. So let's say equals to 9.8 weight of Patrick times, and he's 3 meters. Oh wait, I'm actually doing mass of Patrick, not weight. And then say this is mass of Patrick times 3. So 2730.4, 29.4. Mass of Patrick. Okay, now our clockwise, it's going to equal 9.8. Let's do the beam first. So it's 15 kilograms and it's 1 meter away. And then Dakish is 60 kilograms and he's 5 meters away. 60 times 5. The beam is just going to be the halfway. So since this is 8 meters all the way across, then halfway we need 4. So 3 plus 1 is going to equal 4. That's how I got that length. So this is 9.8, 15, 60 times 5, 3, 87 Newton meters. So then since these are equal, then these must be like that. Oh wait, and Patrick. So for the 37, and Patrick is 105. It's 3 sig fig, so 1.05 times 10 to the power of 2 kilograms. Okay. A simple AC generation in the diagram. A coil is manually rotated in fixed magnetic field producing. Explain how the alternating current is produced, making specific references to labeled parts of the diagram. Okay, I'm gonna have to pull this up, so give me a second. Okay, we're back. I've got the image on my screen. So there's slip rings, carbon brushes, and a coil rotating. So I think I'm gonna say, as the coil rotates, around or within, as the coil rotates, I'm just going to say it experiences a change in flux. And I'll say EMF is proportional to the phi dt, hence an EMF is induced. This EMF or current will change directions every half turn or every half rotation, such that it creates an opposing magnetic field to the change in flux. Field to the change in flux. Okay, then carbon brushes allow for continuous contact to slip rings. Or say slip rings and carbon brushes. Slip rings rotate with coil is attached. Slip rings, which contact stationary hence. So here I'll say hence creating an alternating current. every half rotation. So let's see. So the left hand side is coming up. It's coming up. It's more flux through it. So I'm gonna go this way. Here there's gonna be less flux through it. This is when I swap. There's 0 here. Wrong way. 0 here, 0 flux. But down of change. So then from here, when I go across 0 to some, I'm not sure. Okay, we'll figure it out later. Which contacts stationary carbon brushes, which allow for continuous transfer of alternating current to an external circuit. Okay, going down, a charged particle enters that of the velocity of that, the magnitude it lands on the detector. Calculate the mass of the particle. So radius, this is an R equals mv over qb question. So let's see, I don't have m, but I have velocity, I have my charge, like that, my radius. Okay. So then we have velocity, we know that mass is going to equal RQB all over V. Now radius is going to be half of 9.14, so 9.14 divided by 2 is 10 to the negative 2. So I'm going to have 4.57 times 10 to the negative 2, 1.6 times 10 to the negative 19, times 0.35 times 10 to the negative 3, and my velocity is 2.81 times 10 to the 6. So 4.57, 10 to the negative 2, 19, 3, 2.81. To the 6, so this is 9.11 times 10 to the negative 31 kilograms, which is going to be an electron. So then it's going to be an electron. Oh wait, hold on. So my force is going this way. Okay, let's see. The magnitude of the charge. Okay, so I have to determine, so it's going to be an electron or a positron. So into the page, a positive particle, B is into the page, my velocity has to be going, okay wait, we start from here, so I need my initial force to be going that way, so when that matches the direction, that means it has to be a positive. Positive charge, so it must be a positron. Because if an electron would be going the other way, yes. Okay, so positron. An aircraft with wingspan of 50 meters flies due east parallel to the Earth's surface. The Earth's magnetic field strength at that location. It makes an angle. The vertical, the aircraft is traveling like that. Using appropriate components of the magnetic field, calculate the electromotive force induced between the ends of the aircraft's wings. Okay. So component, so B. So we're gonna assume it's, did they say it's parallel? Okay, it flies parallel. I think we're gonna assume that it's straight on. So we need the upwards component. So let's just draw a little triangle here. That is 33. I'll say that this is B vertical. And this is 5.85 or 5.84 times 10 to the negative 5. So then we got cosine of 33 is going to be equal to adjacent all over 5.85 or 5.84 times 10 to the negative 5. So then V is 5.84 cosine of 33. So this is 4.898 times 10 to the negative 5 Tesla. So then EMF induced is length VB. The appropriate component of magnetic field. So then EMF is going to be LVB vertical. So then it's 50 meters. So 50 times. Let's do 720 kilometers per hour equal to, so 720,000 meters divided by 60 divided by 60, 200 meters per second. So times 200 times 4.89 times 10 to the negative 5. So this is 0.489 volts. Okay, a wire runs between the ends of the wings, parallel to each wing, so as to set up a complete circuit. A sensitive ammeter is placed at the circuit. If the total resistance is 1.78, what will be the reading of the ammeter? Well, V equals IR. This is odd that they have this question. IR. And the ammeter, so then I is equal to voltage, which would be 0.489, over resistance, which is 1.78. You don't usually have these questions. 0.25 or 275. Okay, when does section 2 start? It starts on page 15, right? Two identical 25-gram coins are placed on a rotating disc, 0.3 and 1.2 respectively from the center. The disc begins to rotate when the frequency of the rotation reaches 2 Hz. The outer coin flies off this. Calculate the frequency of rotation when the inner coin flies off. So it's going to be some, is it the friction force? Say it's the friction force that holds it in. Okay. So let's say for coin 2, so it's reaching 2 Hertz, so 0.5. So let's say V equals, coin 2, velocity equals 2 pi times 1.2 all over 0.5. So this would be 15.08 meters per second. So I'm going to find the centripetal force because that's going to equal the frictional force. And then equals that. And then F of C is going to equal mv squared over r. And they're both 25 grams, so 0.025 times 15.08 squared all over 1.2 is 4.74 newtons. Now Fc equals F of friction so that's the max friction that can hold the coins in, and for coin 2 max F friction equals Fc max, so then 4.74 must also equal mv squared over r. So then velocity is 4.75 times, the radius is only 0.3. Maybe for here I write t equals 102. It's 2 hertz. And then you divide this by my mass, which is 0.025. So this gives me 4.74. 0.3, 0.025, 7.54, 7.54 meters per second. And we want to calculate the frequency of rotation, not just the velocity. So then t is equal to 2 pi r over v, so it's going to be 2 pi times 0.3 all over 7.54. So 0.250 seconds. So then frequency is going to equal 1 on t, or 1.0.25. That's just going to equal 400 hertz. Okay. Question 9. A group of students places a metal bar in a DC circuit. As shown in the diagram, the bars are arranged horizontally between the plates. They turn on the plates and notice the bar moves. Which direction is the initial movement of the bar? Okay. Let me get this one up. I already have the file up, so I don't have to pause. Hope not. Okay, here we go. So I have my I have a current. So there's a direction of positive forces. I don't think it much. I think this is one of the questions people are talking about where there's not enough information to actually do it. Because I don't have a direction of the magnetic field on the horseshoe. So I'm going to say I can't do this one. I'll see later in the marking key what it says. Explain why the bar moved when the circuit was turned on. When the circuit was turned on, charged particles started to move throughout the bar. And then maybe I'll say F equals QVB. With B now being the permanent, I said permanent, right? Permanent horseshoe magnet. Oh, I just said horseshoe magnet. Being front horseshoe magnet. These charged particles would field and a magnetic force. Magnetic force on them. Hence this would accelerate. Accelerating the bar due to the sum of magnetic force felt by the charged particles, thus moving it. Thus moving the bar. A current flows through the bar, or a current which is comprised of that. Okay. Two identical solid and uniform spheres are separated by a distance of 10 meters from surface to surface. The distance between their centers is called d. If each sphere has a mass and a diameter of that, calculate the gravitational force between them. So let's say d equals 12 meters. The distance between them is 10, and then each one is 1 meter to its center. So this is just going to be an F equals big G equals G m1 m2 r squared, subscript 2 r squared. So this is 6.67 times 10 to the negative 11 times, they both have a mass of 12.5, so 12.5 squared all over 12 squared. 6.67 10 to the negative 11 times 12.5 squared divided by 12 squared is 7.24 times 10 to the negative 11 newtons. 7.24 is 10 to the negative 11. Okay, that's a 4-mark question. On the axis below, show how the gravitational force between the two spheres varies as they move apart. Indicate the magnetic force on the y-axis as the points 2D and 4D. Use 7.5. So at D, we are at 7.24. 7, so then this is probably about 7.4. Line this up well. So around there. So then as the radius becomes twice as big, I'm going to get a quarter, so it's going to be twice, so I need to divide this by 4. 7.24 divided by 4 is going to be 1.81. So let's see, 1.8, let's put about there. Come on, make a 90 for me, there we go. So about there. And then, so let's do 7.24 divided by 9, so 0.8. Include the magnitude of the force, 3, and then 7.24 divided by 16 is 0.4. Well, 4.5, so maybe we go about there a little bit higher. Okay. Next below, and get rid of that. Indicate the magnitude of the force at 2D and 4D to obtain an answer. So I guess let's draw a reciprocal graph. Maybe if I make these more like spheres, it's probably a bit nicer. Oops, did not mean to get rid of both of them. Go away ruler, just like that. You need to be a dot, and you need to be a dot. Come on. What? How am I erasing this field before erasing the line? What? Bro, my eraser's bugged. I'm coming in from the left. What the heck, man? Okay, whatever. It's fine. Let's try and connect these dots together. Oh, if we hide it like that, that's smart. Oh my god, professional sketcher right here. What the heck? Okay, and then they want us to indicate 2D. So 2D was 7.24 divided by 4, which is 1.8. 1.81, so I'll say 2D. And for 4D, it was 7.24 divided by 16, which was 0.45. 4D is 0.423. Oh shit, that's fine. Okay, yep. Two parallel conducting metal plates are held at a potential difference of 10 volts. An electron in a vacuum arrives at a small hole in the first plate with 20 electron volts of kinetic energy and travels through the electric field as shown. Calculate the divergent wave as it exits at B. Okay, so I need to find the velocity. So, increase in energy is going to equal is V times Q. Because that's going to be force times distance. Okay, so let's say W equals QV. So it's going to be 1.6 times 10 to the negative 19 times 10 volts. So I'm going to get 1.6 times 10 to the negative 18 joules of energy. It already has 20 electron volts. So let's do 20, 1.6, 10 to the negative 19 is 3.2 times 10 to the negative 18 joules. So then total EK is going to be 4.8 times 10 to the 18 joules, and therefore 4.8 times 10 to the negative 18 is going to be half of mass velocity squared. So the velocity is 2 times 4.8 times 10 to the negative 18, or over 9.11, 10 to the negative 31. You know what I should do, guys? I should do, what do you call it? I should make like a prediction of my ATAR results, because I'm gonna finish my exams, because the results come out like a month after, so maybe I'll definitely have time to like think about how I did. Yeah, I think I'll do that. Okay, let's do this. So this is 3.246 times 10 to the power of 6 meters per second, and we know that lambda equals h over mv, and that's what I want us, right? Yeah, the Berkeley wavelength. So then this is going to be 6.63 times 10 to the negative 34 all over 9.11 times 10 to the negative 31 times 3.246 times 10 to the 6. So I get 2.24 times 10 to the negative 10 meters. Does it want in nanometers? No, okay, so 2.24 times 10 to the negative 10 meters. In a video game, the players fire arrows from the top of a 30-meter high castle at a flat 4-meter wide target moving in a circular path with the radius of that. The players can adjust the vertical angle. Oh, but the direction of fire is fixed. Okay. The launch speed is also fixed at 50 meters per second. It takes 32 seconds for the target to complete one revolution of the tower. The shooter fires the arrow when the target has 45 degrees or a full revolution to go. What angle theta must have the horizontal for it to hit the center of the target? launch speed is fixed at 50 meters per second. It takes 32 seconds for the target to complete one full revolution of the tower. Angle theta must fire above the horizontal for it to hit the center of the target. .45 degrees of full revolution to go. Okay, so let's say so time is going to be 45 over 360 times 32. Is it? What does that even give me? Divided by 360. 32 seconds. 4 seconds. Well, it takes 4 seconds for it to complete that side. To rotate that way. Four seconds and 50 meters per second. Theta. So the 195 must equal 50 cosine of theta times 4 must equal, so the theta is going to equal the inverse of 195 on 200. I'm not sure about this question. .8 degrees. The user confirm that the arrow hits the target. Because this bit here, my time, is assuming that we want it to hit the target exactly when that thing comes around to the thingy bobby. But now I'm not so sure. Because it needs to travel. The shooter finds the arrow when the target has 145 full revolution to go. Not so sure. Confirm that the arrow hits the target. So let's say that U sine of, or 50 sine, 30, oh no, 12.8. I guess I'll see here if it hits. It's going to equal UV. So 50 sine of 12.8 is 11.08 meters per second UV. So then the S is going to be 11.08
times 4 seconds minus 4.9 times 4 squared. This is nerve-wracking. I don't know if I'm going to get the right answer. 4 squared, negative 34. Negative 34 meters and 30. 7.8. 4 seconds. 50 sine of 12.8. Answer times 4 minus half of 9.8 4 squared, negative 34 meters. What will it have to be? Let's see. Sine of 50 sine, let's say 11. Let's say 12 times 4 minus 4.9 4 squared is 36. 13 meters. 15 meters is too much. 14 meters. It needs to be 14 degrees. Confirm that the arrow hits the target. Eighth of the thing left, 32 seconds to take a full rotation. Not so sure. I think this might be we leave it and we come back in it for it in a second. Anchor should have found the arrow above the horizontal frame to hit the center of the target. Oh wait, no, I think I understand now. The target moves, not us shooting it. So the time it takes is going to be 4 seconds. But let's say, wait, but then that should work. Okay, what happens if I say that negative 30 will be equal to 50 sine of theta times 4, so 200 sine of theta, minus 4.9 of 4 squared. So let's say negative 30 plus 4.9 of 4 squared is going to be 48.4 equals 200 sine of theta. So then theta is going to be inverse sine of 48.4 divided by 200. Aha! 14. Okay. 50 cosine of 14 times 4. 194 meters. What? I'm slightly off if I go either direction. Theta equals sine negative 1. 48.4 on 200. So 48.4 on 200 is 14.0 degrees. So we'll say here UV equals 50 cosine of 14.0, so it's 14. So then distance is going to be 50 cosine of 14 times 4. meters. It's a 4 meter wide target. Hits the target. Before it hit the center of the target. To hit target must be. Oh wait, I think so. I think S must be. Because that's 195 and it's 4 meters wide, so it can actually be 2 meters on either side. So 139 meters to 197 meters. And 193 less than 194 less than 197, therefore hits target. Okay, nice. Salmon and Priyakana has identical 1 meter rulers. Priyakana takes a ruler and sets off in a rocket. She travels past Salmon at a speed. Like what it says for it to hit the center of the target. If you want to hit the center, that has to be 195, doesn't it? Damn it. Or I'm just going back and forth, back and forth. I'm just going back and forth, back and forth. You know, it says center of target, so I think I have to do the other way. And let's say that 195 for center. But then I don't know how to do it the other way. That's horizontal. So this is equal to 50 cosine of theta times 4. So then theta is cosine negative 1. 95 and 200, which is 12.8. Calculation confirm that the arrow hits the target. And then S is 50 sine of 12.8 minus negative 9.8 times 4 squared. Sine of 12.8 times 4 minus 4.9 times 4 squared. So it's negative 34 meters though. 34 meters. Negative 34 meters. I'm just going to say target is 30 meters below. Therefore, hits target. I don't know. I'm not sure how that's going to work. Salmon and Pelican have identical 1 meter rulers. Pelican takes a ruler and sends something a rocket travels past at the speed of 0.8. The meter rulers are aligned in direction. Each then travels the length of each of the other's ruler by carefully determining the position of each ruler at the same instant, measuring the distances between these positions. How long does Salmon measure Pelican's ruler to be? So it's just going to be L is equal to 1 square root of 1 minus 0.8 squared. 1 minus 0.8 squared. So 0.600 meters. How long does Priyakana measure Salmon's ruler to be? So since Priyanka sees that Salmon is the one that's going to be traveling at 0.8 c. Same instance. Okay, so there's also going to be the same. So 0.600 meters. To share the competitive measurement, how they're able to explain the seemingly contradictory results. For instance, I'm measuring the distance between these positions. How do I to explain? Wait, so maybe here I'm just supposed to say 1 meter. So I'll say Priyanka measures Salmon's stationary ruler. No, but Priyanka should see it be 0.6 meters, right? Because she's definitely not going to see. She's not going to see the proper. Stationary ruler. Two different wait. The position of each end of the ruler at the same instant, measuring the distance between these positions. The rulers have been length contracted. Due to Priyanka's relativistic velocity. I don't understand. Explain the seemingly contradictory results. How long does Salmon measure Priyanka's relativity? So Salmon definitely measures it to be 6. How long does Priyanka measure Salmon's rule to be? Should also be 0.6. Because from Priyanka's perspective, Salmon is moving at 0.8 c. Each then measures the length of the other rulers by determining the position of each end of the ruler at the same instant. Measuring the distance between these positions. At the same instant. Hence the endpoints of the ruler will be contracted together. Because with respect other's frames of reference, the other person is traveling at 0.8c. Thus, they are not able to get, thus they are not stationary or making the measures. Respect to the other person's ruler. Since they are not stationary, thus cannot measure proper length. Okay, I think I kind of butchered that one. Let's see, an ultra lightweight 2 kilogram aluminum plank is suspended between two 70 kilogram freestanding supports as part of the children's obstacle course. It is attached to the supports by two chains of equal length. Due to safety restrictions, the apparatus has a maximum load of 60 kilograms. The father with a mass of 80 mistakenly sits on the plank. Halfway between the two, his mass exceeds the ceiling, should tip inward. Calculate the tension each chain on the father side of the plank, assuming the supports do not tip over. So let's see, around P. The father sits on the plank. So I'll take moments around P. And let's see what I'm dealing with here. So sum of the anti-clockwise is going to equal sum of the clockwise. And the sum of the anti-clockwise is going to be, so I'm going to have a tension force coming up here. I'm going to have the force of the father. This is 8. And an ultra lightweight 2 kilogram plank. Anti-clockwise is going to be, sorry Duolingo, can't do you now. Anti-clockwise. Oh no, I'll take moments around B actually. Clockwise. So I'm only gonna have this anti-clockwise around B is gonna be the weight forces. So 9.8 times 80 times equal length times radius plus what is this? This is going to be 2 times, or half, let's say this is half of diameter. D plus 2 times half of D. This is equal to 9.8 times 80 times 0.5 plus 1, so 393D. Let D equal length of plank. It doesn't actually look like there's a solid length of the plank here. And then clockwise is equal to sine 30. No, actually cosine of 30. Force of tension. So force of tension cosine of 30 times D. I believe. So I'll beat that. And this is my force of tension. Vertical, so F of T. Cosine is going to equal FTV over FT. I want FTV, so times that, yep. So it's going to equal cosine of 30, which is 0.866 FTD. So then 399 D equals 0.866 F of tension D. So then force of tension is going to be 393 over 0.866. So 554 newtons. Okay. Calculate the horizontal component of the tension in each chain. So then this would be F of T. So here Ft of other chain is identical due to symmetry. Okay, so horizontal component is going to be H is 454 sine of 30, which is cosine. Is that cosine of 30? Yep, 454 cosine of 30, I mean sine of 30, sorry, is 227 newtons. Meters. With use of calculation, confirm that the supports do not tip over when the father sits on the plank. Take moments around P. So P. So I'm going to have the tension force and this guy. So I'm going to have a mass force here. I'm going to have a force of mass here as well. I'm not sure. So let's say some of the anti-clockwise force is going to be so I have the gravity and that's it. Moments around P. So at B I'm going to have this upwards tension. So we have 9.8 times, and how heavy are the blocks? 70 kilograms. So 70 times, and it's 0.4 away. Is equal. And then we have plus force tension vertical times. So let's say 454 cosine of 30 plus times what am I going to say here? Oh, because these are all going to be pulling over there. Right. So let's just say this. 454 cosine 30 times 1.5 is going to equal. Wow, I think I'm very far behind, guys, at time. 1.5 16 meters. Clockwise is 9.8 times, then let's see, 60 times 1.5 plus, because this is my perpendicular, it's going to be pulling that way, plus 2 times 1.5. So that is 9.8, 60 times 1.5 plus 2 times 1.5. I get 911.4, which means it's greater than, which is not good. This may be 2 times. So let's do this times 2. $454 cosine of 30 times 1.5 times 2. It's 9.8 times 70 times 0.4. Wait, let's take this up here. Okay, I think I have a smarter way. Let's say sum of y. The plank is going to be 9.8 times 60 plus 2 minus 2 times 454 cosine of 30 it's negative. Oh wait, mass of 80. There we go. cosine. Guys, I feel like I'm spending way too much time with this question. Wait, that's only 17.25 newtons down. Sum of the anti-clockwise is going to be equal to 9.8 of 70. So 274.4 newtons. Wait, what? Am I doing this right? I don't think I'm doing this right. Whatever, I'm just going to go with it because I'm running out of time. Clockwise is equal to 25 times 1.5. So it's 25.88. It's going to be greater than the sum of the clockwise force. The supports do not tip. Yeah, I spent like 20 minutes on that question. Without using additional, how does the tension increase sitting at, if a 50 kilogram person sitting at A move to B, chain 2 would increase, and then chain 1 would decrease. Collision after collision. A stationary free electron and a photon collide. In such a collision, both momentum and energy are conserved in one such collision, traveling in the direction shown in the diagram. After the collision, the photon turns in direction. The new wavelength of light, and the electron is no longer stationary. The particles are produced. What is the original energy of the photon and electron volts? So we'll say E equals 6.63 times 10 to the negative 34 all over C over lambda, so times 3 times 10 to the 8 over lambda, which is 7.04 times 10 to the negative 11. 7.04 times 10 to the negative 11. So then this is 2.83 times 10 to the negative 15 joules. And 2.83 times 10 to the negative 15 divided by 1.6 divided by 10 to the negative 19. This is going to give us 1.77 times 10 to the 4 electron volts. What is the momentum of the photon before the collision? So then we know that lambda equals h over mv over p mean. So then p is equal to h over lambda. So it's going to be 6.63 times 10 to the negative 34. 7.04 times 10 to the negative 11. 7.04 times 10 to the negative 11. So this is 9.42 times 10 to the negative 24. Just thinking about the above question, this one. Moments around P. Because we'll be pulling inwards like that, but at an angle. Only that force of tension, isn't it? So that would be force. Let me try that. Sum of the clockwise is going to be 4.4 454 cosine of 30 times 1.5 times, and then it'll be cosine of 60. 294. 294. He's 80, so let's say this is 294.8. Ah, this looks more like it. Okay, I'm pretty happy with that, because all I have is that force of tension that acting down on it, and that's 60. And then, so then this is the force perpendicular. So cosine of 60 is force perpendicular to Ft. Okay, nice. I think that's what they're going for. Phew. Okay, explain why the wavelength of the photon is greater after the collision. After collision. Wavelength of that. The electron is no longer stationary. After collision, electron is no longer stationary. Therefore has some momentum. Thus to maintain conservation of momentum. Well, let's go in an opposite direction though. Conservation of momentum. I'll say initially to the right. Photon going to left must have a decreased momentum. So we'll just say decreased velocity to left. And as lambda equals h over p, when p decreases, lambda will increase. Must have a lower momentum than initially. Calculate the speed of the electron after the collision, hence use the conservation of energy. Okay, so before photon had 1.77. E of photon is 1.77 times 10 to the 4 electron volts. 4 times 1.6 times 10 to the negative 19. So this is 2.832 times 10 to the negative 15 joules. Now I don't have to worry about the mass, do I? mass will be the same in both. So then afterwards, (2.832 times 10 to the negative 15 is going to equal the energy of the photon. That's the kinetic energy of the electron. This is going to equal 6.63 times 10 to the negative 34 times 3 times 10 to the 8 all over the new wavelength, which is 7.525 5 times 10 to the negative 11 plus kinetic energy of the electron. So kinetic energy of the electron is going to be minus 34 times 3 times 10 to the 8 to 5 10 to the negative 11 1.888 times 10 to the negative 16 joules. So then half of mv squared is going to be 1.888. So then v is going to be the square root of 2 all over 9.11 times 10 to the negative 31. I'm gonna have to do relativistic stuff. I hope not. Three, 4, 5, 6, 7. 2.03 times 10 power 7 meters per second. Alright, page 20. When a stationary neutron decays into a proton, an electron interaction, filling in the tables. The baryon number is 1, 0, 1, 0, 0, 1, and this is 0, negative 1. The mass of a stationary electron, antineutrino, yeah. The mass of a stationary neutron is that. The mass of a proton, the mass of an electron, if we assume the energy is that, calculate the total kinetic energy of the particles emitted. Electron volts. So then let's say E of 0 is equal to 1.675 times 10 to the negative 27 times 9 times 10 to the 16. So then this is 1.5075 times 10 to the negative 10 joules. The energy of proton is equal to 1.673 10 negative 27 times 9 times 10 to the 16. 5057 10 to the negative 10 joules. And then electron is equal to 9.11 times 10 to the negative 31, 9 times 10 to the 16. Is 8.199 times 10 negative 14 joules. So then kinetic energy released is the left hand side minus 1.5057 times 10 negative 10 minus 8.199 is 10 negative 14. Negative 10 minus 1.5057 negative 10 minus my answer. So 9.801 times 10 negative 14 joules equal to 6.13 times 10 to the 1, 2, 3, 4, 5 electron volts. So 6.13 times 10 to the 2 kilo electron volts. 6.3. If an electron accounts for 90% of the kinetic energy produced, calculate the velocity of the emitted proton. Determine emitted proton. When does section 3 start? 32. Okay, so then here the proton is going to be 0.1 kinetic energy produced. So it's going to be 6.13 times 10 to the 2, so 1.6, 10 to the negative 19. So this is 9.808, 10 to the negative 18 joules. So then 9.808 times 10 to the negative 18 will be half of 1.673 27 times v squared. So the velocity 2 times 9.808 negative 18 over 1.673 times 10 to the negative 27. One 1.08 times 10 to the 5 meters per second times of c. So 1.08 times 10 to the power 5 divided by 3 divided by 10 to the power 8. 3.60 times 10. Maybe I should go the full number. Eight 28 times 10 to the power of 5 meters per second. 0828 times 10 to the 5. Now I don't trust myself. I feel like I got that wrong already. Divided by 10 to the power of 8. 3.61 times 10 to the negative 4 c. Alright. I think I'm going to leave these guys here. yeah, I think I'm gonna leave this because it's already 10:30, so I'm gonna head to bed. I'll finish the rest of the exam tomorrow, and I'll do the 2023 WACE exam tomorrow as well. And then yeah, we will. Then Wednesday will be the physics exam, so that'll be fun. Yeah, later, and we're back. Let's go on. We were up to this page. So fill the table using the value. Oh wait, hold on. Let me turn my. Okay, we're back. We got up to here. So giving answers to 3 significant figures. 1 on lambda, 2 to 1. You see. So the wavelength. Okay, let's do the bottom line first. So from 2 to 1, we emit a 122. So 6.63 times 10 to the negative 34. Oh, I know, this is just 1 on 122 times 10 to the negative 9 divided by 10 to the power 6. So I get 8.19. Or 1, actually it's 8.20. 3 to 1 is 3. 10 to the power 6 times 1 over 3 times 10 to the negative 9. So this is 9.71. 4 to 1 is 97. 7 is 10.3. 5 to 1 is 95. 6 to 1 is 94. Is 10.6. Okay. And 1 to n2 electron transitions. So n1 to n2. So is that 1 on 1? So 1 on 1 minus 1 on 4. So 3 on 4. 3 on 4. Next one is 1 on 9, so 8 on 9. Oh wait, 0.750. See, I think this is quite ambiguous because there it says n1 equals 1, so then n1 equals 1. So n1 equals 1. So yeah, okay. So this is 0.889. And it'd be 1 on 16 is 0.938. 1 on 25 is 24.960. 35, 36 is 0.972. So label x-axis. So then this is 1 on lambda. And it'll be 10 to the power 6 meters. And then this value here is going to be 1 on n1 squared minus 1 on n2 squared. So let's go 0.75 and 8.2. At least this graph is nice to graph on 8.2. 889, 971, 889. 6, 7, 8, 8, 9, put it up there. And then 9.71. There. And then 938, 10.3. So 1, 2, 3, so 8, and 10.3. It's 10, 3, 960, 10.5, 60, 10.5 is there, 972, 10.6. So 2 across a little bit, and then about there. Okay, now I'll draw a line of best fit. What's a good line of best fit looking like for this? Or something like that. A little bit lower. Yeah, I think something like that's pretty good. Okay. Line of best fit to calculate the whatever constant, indicate clearly the point you have used. So I used, let's see what point I'm going to use. Let's use this point. That's a pretty nice point, which is 0.74 and 8 to, that's another nice point. Let's use this point here, which is going to be, let's do open circles for these guys. So there, and there. It's going to be 1, 2, 1, 2, 0.975 and 10.7. Okay, so that M is going to be equal to, actually wait, let's write the points in. Open circles for points. And then this was 0.74, 8 to 0.975, and 10.7. And M is going to be equal to 10.7 minus 8 times 10 to the 6 all over 975 minus 0.74. 10.7 minus 8 times 10 to the power 6, 975, 0.74. I get this is 1.149 times 10 power 7. And M is equal to, so let's see, 1 lambda. So M is equal to 1 on lambda over 1 on n1 squared minus 1 on n2 squared. And now 1 on lambda is equal to r over hc times 1 on n1 squared minus 1 on n2 squared. So then r is going to be equal to 1 on lambda over this 1 on n1 squared minus 1 on n2 squared times hc. So that's just equal to mhc, which is going to be 1.149 times 10 to the 7, 6.63, 10 to the negative 34 times 3 times 10 to the 8 is equal to 3 times 10 to the 8, which is 2.3, because 2 sig figs, 10 to the negative 18. Let's just say, so 2.3. Alrighty. forgot how much there is still left. So, okay, this equation can be applied to one electron ions of different elements. Formula is modified to that. Identify and explain two differences you would see between the graph of that and that. So then R4 if I rearrange this, I'm going to get M is going to equal Z squared R on HC. So obviously for helium, this is going to be times 4 because it's 2. So steeper gradient. And R is constant, right? Yeah, it's constant, okay. Helium as M would equal Z squared. RHC compared to for hydrogen, M would equal 1 squared R of HC. And I'll say due to helium having 2, having 2 protons. That's increasing Z. Okay, what's another thing? What's another difference I would see? Would it just be that like y-intercept would be lower? So I have a gradient higher. So y-intercept lower due to steeper gradient. I don't think I'm going to get that mark though. Not exactly sure what else they want me to say. Okay, well, I'm just going to continue then.
Figure 1 shows the power station that supplies electricity to a small community. The homeowners decided to switch from DC to AC generators to save costs and reduce greenhouse gas emissions. Okay, calculate the power output of both stations in kilowatt hours or kilowatts. So the power is just equal to the VI. So let's say AC. This is going to be 4,800 times 10. 4.8 times 10 to the power 4 watts, which is 4.8 times 10 to the power 1 kilowatts. And then for DC, just equal to 480 times 100. So 4.80 times 10 to the 1. And then 4.80 times 10 to the 1. If the resistance in the transmission line between the pylons is that, estimate the efficiencies of both systems by calculating power loss in the wires. Assume negligible power loss in the lines to the wires from the station and from the pylons to the houses. I think I've seen this question before where they have clearly two wires there. So we need a double, so like effective length is 20 kilometers. So let's say effective length is 20 kilometers for each. Two 10-kilometer wires. So then resistance is going to be 2.19 times 10 to the negative 4 times 20 times 10 to the power of 3. So I get 4.38 ohms. And now power loss is going to be, I can just do IR squared. So P, let's do AC. P loss is going to equal I squared R. And for AC, it was only 10. Yeah, 10. So it's 100 times 4.38. Is equal to 438 ohms. No, watts of power. And for efficiency is equal to 100 minus 438 on 4.8. It's 10 to the power 4 and 100. So this will give me 99.1%. 2.19 times 20 is 4.38. Okay, and then DC power loss is going to be 100 squared times 4.38. So this is 43,800 watts. Yikes, what the heck, bro? That's terrible. And then efficiency is going to be 100 minus 43800, 4.8
times 10, 4 times 100. So this is only 8.75%. Nice. So DC is 8.75. And then AC is, was it 99.1? That seems very high, but I guess it is what it is. Okay, step 3 shows a step-up transformer. One of the features that increases is the laminated soft iron core. Explain why laminating the core increases the transformer's efficiency. So laminating core reduces the ability, reduces the size of eddy currents that may form in the core, and then this reduces energy or power loss due to resistive heating. In the core, resistive heating from the eddy currents. Thus reducing energy loss, thus increasing already said reduces energy or power loss, so thus increasing efficiency. Okay, explain why transformers require AC current to function in electricity transmission. A transformer works by creating or generating a changing magnetic field that induces a changing magnetic field induces a EMF in the second coil. This changing magnetic field is produced by changing the alternating current by the first coil, by the initial coil. Produced by the primary coil, which can only occur only induce an EMF in the second coil. If the primary coil's magnetic field is changing, let's say EMF proportional to the theta dt, hence AC is required. As it alternates direction. Alternating, constantly changing the magnetic field. Constantly. Come on, let me undo. Magnetic field. And then with DC, magnetic field around the wires of the coil is constant. Thus do not induce, thus does not induce an EMF in the second coil. As rate of change, flux zero. Field, and I say flux. And then let's go down 30. Calculate the tension when theta equals 30. Okay, so I have a bulb. Mass is 25, and length is 1.2. Frequency of the rotation is that. Calculate the tension in the string. Okay, so then I know that that bad boy, like upwards, for the tension, is gonna be, and here's gonna be my 30. And I know that this must be mg, or force of tension vertical. So F of tension vertical must equal mg. So this is going to be 255 times 9.8, which is 2.499 newtons. And the force of tension is gonna be vertical. So it's gonna be 2.499 all over cosine of 30. So I get 2.89 newtons. Calculate the radius of the circular path is moving when the angle is 30 degrees. The length of the pendulum is 1. So we draw the triangle. This is 30, that's 1.2, and this is r. So the radius is going to be 1.2 sine of 30. So 0.6, is that meters? Meters. So then, oh wait, that's it. 0.6 meters. 0.60. Calculate the new angle between pendulum string and the vertical if the frequency of the rotation is doubled. Okay, so frequency of rotation doubled. That means that my UF is equal to 0.98 hertz. So then time is going to equal one divided by 0.98 is 1.204 seconds. And the velocity,
No, know that my force of
tension horizontal is going to equal mv squared over r. And force of tension horizontal now is going to be horizontal. So tangent is opposite over adjacent. my adjacent, I don't know my opposite. So it's going to be tan of theta, or FTV tan of theta, which is mg tan of theta. It's going to be 0.255 times 9.8 tangent of theta. So again, 2.499 tan of theta. And then my velocity is going to be 2 pi r over time, where my radius is going to equal 1.2 sine of theta. So then my velocity is 2 pi r, 2 pi times 1.2 sine of theta, all over my time, which is 1.0204. So then summing this all in, 2.499 tangent of theta. I think I'm going to write tangent of theta as sine of theta on cosine of theta. It's equal to 2 pi times 1.2 sine of theta over 1.0204. So I can divide by sine of theta. Divide everything by sine of theta, multiply this cosine of theta to the right hand side, and then rearrange. So let's do 2.499 times 1.0204 over 2 pi times 1.2. It's going to be equal to cosine of theta. So then theta is just going to equal the inverse cosine of what this is. I'll try the full thing. 499 times 1.0204. So cosine 2.499. I get 70.2 degrees. Does that make sense? Does that make sense? Yeah, I think so, because I can imagine when you're spinning something, it starts to get up. Because if you're holding it still and you're not spinning it, it's going to be straight down. Okay. I think that makes sense in my brain. So 70.2. Explain why theta can never equal 90 regardless of how great the frequency of the pendulum becomes. You may use mathematical relationships in your answer. There must be some tension force if theta equals 90, and the relationship between horizontal tension and magnitude of tension which would be Ft horizontal equals force of tension cosine of theta. Cosine of 90 equals 1, therefore force of tension equals force of tension horizontal. Thus there is no what do you call it? A vertical component to tension. However, thus the vertical component of tension is equal to 0, then there is no opposing force of weight, opposing force to weight. Thus, it would bring accelerating the ball, or accelerating the pendulum down, to a theta be less than 90 degrees. There's no opposing force to weight. Thus, hence, theta can never equal 90, as there must be some opposing force to the weight of the pendulum. Opposing force from the tension oh wait, no, this is sine of theta. Wait, did I get this right then? Tangent. Yeah, that's right. And here, did I get it right? 1.2 sine, yes, because it's the opposite. Yeah, I think that's good. Sine of theta. Cosine of 90 is not. It should be sine of 90. Sine of 90 equals 1. Never equal. There must be some opposing force from the tension to the weight of the, I'll say here, vertical component. So weight of the pendulum. Alright, comprehension section. Light emitting diodes. Okay, I feel like I'm going to need this text. Let's just have a see. Yep, I'm going to need this text. Okay, I'll be back then. Pause. Okay, I've got the article up. So what's this first question? Explain how a p-n junction produces visible light. Where does the light in your house come from? Chances are it comes from a variety of different types of light sources, but an increasing number of them consuming LED during the phosphorescent incandescent fluorescent main way to cure the curse of darkness. Motion, radial flame light. It was not heating up, it was emitting light through another under method. Electroluminescence, a scientific oddity. Infrared, semiconductor, radiant diodes, some gallium arsenide. We should probably only omit one. It's fine for a calculator display, but it doesn't work for lights that illuminate your house. You need to give a range of frequencies. LEDs only give a very small narrow band based on the electro. Inside, combination is called a p-junction. So let's say a p-n junction is between a p-type material and then let's say p-type has what's the opposite of excessive? Excess. Deficient, electron deficient. And n-type material. And then we'll say this is electron excess. Electrons, these two materials are held at different, they have different energy levels. As the electrons flow from an end energy level dropping from a higher energy level, higher energy level of the p-type. Wait, no, I accidentally clicked up. This contamination means that one layer has lots of high energy electrons that want to give away. One layer is N, the one that wants to give them away, so it has lots of electrons that it really wants to fill at a lower energy level. The other is p-type, the other layer that it really wants to fill at a lower energy level. I think there's an error in this article actually, because it says dropping from a higher energy level of the p-type layer to the lower one of the n-type. Okay, I'm gonna search up, is p-type material higher energy level than n-type? Greater energy relative to the n-type conduction band. I think I'm just going to say that n-type material so high energy electrons from the n-type will cross the boundary, cross the p-n junction, and fill an empty space for electrons in the p-type material. In the p-type, it is a lower energy level, thus energy level for electrons is lower than that n. N-type. Thus, the electron emits a photon equal to this, to the difference in energy. A specific, this photon may have a lambda in the visible range, depending on energy. Thus is visible light. A bit of a push one where they fall over, but they can't go back up. Flow from the N to the P layer. Okay, never mind. I'm just gonna quote verbatim the text. Once the N is the one that gives away. Flow from the N to the P layer. So they flow from N to P. So the text says it flows from N to P. The energy level of the electrons falls, dropping from the higher level of the P type to the lower one of the N type. Electrons, I'm going to say, will flow from electrons will flow from the N layer to P layer. And the P layer of material is higher than an N layer, that's the electron, to the lower one. The law of conservation energy states that energy is neither created nor destroyed, it only moves from one place to another, from one type of energy to another. LED and incandescent are equally efficient at converting energy drawn from their mains into different types of energy. Why does then the passage state that LEDs are far more efficient? References must be made to the graphs of intensity versus wavelength. Spectrum of incandescent. Incandescent. So incandescent light bulbs. produce large amounts or high intensity of longer wavelength, lambda photons compared to white LED. I'll say as well as, that S does not look like an S. As well as physical light. Into white LED, which produces mainly wavelengths visible to light. Mainly lambda of visible light, I should say. It's incandescent. WACE energy producing non-visible light. High intensities. Meaning the efficiency of power draw to visible light. Production is less. Is much lower than an LED that produces majority of its uses majority of its power draw or energy draw to produce visible light. Lots of energy producing non-visible light. Okay, the efficacy of a particular LED is 120 lumens per watt. In the passage and on the table in 33, calculate how much current you need to run through a blue SiC LED operating at minimum VF to produce 840 lumens. So SiC LED is 840 lumens. 840 over 120 lumen per watt. So that's going to be 7 watts. Then minimum VF is 360. Wait, 3.6 or 360? It was 3.6 right here. 3.6 volts. Therefore, power equals voltage times I. So then I is going to be 7 over 3.6, which is 1.94 amps. Okay, with the use of his calculation and data from page 33, Show how the minimum VF crystal is large enough to produce photons with the lowest energy required for blue light. Lowest energy required for blue light is going to have the largest wavelength. So lowest energy pH is going to be Hc over lambda. So this is 6.63 times 10 to the negative 34, 10 to the power 8 all over 505. It's 10 to the negative 9. So I need 3.94 negative joules. And then work of an electron is going to be VQ. Is going to be 3.6. 3.6 times 1.6 times 10 negative 19, which is 5.76 times 10 to the negative 19 joules. I think this is what they want, so then as energy of electron is greater than EPH, it is enough to produce blue light. Enough to produce blue light. So energy of the electron, that's that. Light accounts for 15% of global electricity consumption. Roughly 40% of this is supplied by LEDs. Each ton of coal produces 21 gigajoules of energy. 80% of the world's energy consumption is derived from fossil fuels. Use efficiency, saying to estimate the mass of LEDs if 100% of lighting is provided by LEDs. So lighting energy is equal to 0.15 times 194 times 10 to the 18, which is 2.91 times 10 to the 19 joules. Percent of the world's energy consumption is derived from fossil fuels. Roughly 40% of this is supplied by LEDs. I need efficiency stated in the passage. What is the efficiency so it looks like 10 watts of energy to 60 watts of energy to 10 maybe? Is that what they're looking at? 40% of this is supplied by LEDs. E-LED. So let's say from passage. Oh, sorry, 60 watts per LED. I mean for incandescent. For energy from an incandescent. Equal to 0.6. So 40% energy to LED and 60 to incan. 0.6 of 2.91 times 10 to the 19. Come on, calculator. So 1.746 times 10 to the 19 joules. If or LED, we'll save. Will only be, so I'm going to have 0.4 of the total, so 2.91 to 19 joules plus 1/6 of the incandescence. So it will be 1.451 times 10 to the 19 joules. So then delta E is this 2.91 minus 1.451 times 10 to the 19. So 1.459 times 10 to the 19 joules. E from fossil fuels saved is going to equal an eighth of this, so 80%. Is 1.1672 times 10 to the 19 joules. So then tons of coal is 1.1672 times 10 to the 19 all over 21 gigajoules, so 21 times 10 to the 9. I feel like this is going to be a really big number. 6. Yeah, no, I think I'm definitely off here somewhere. Okay, I'm just gonna leave it. If I get like 5.1, 2, 3, 4, 5, 6, 7, 8. Is it an estimate? Oh, it is an estimate. So 5.6 times 10. 7, 8 tons. There is no way we are mining that much. Actually, I guess we would be using that a lot. What the heck? 80% is derived from fossil fuels. Okay. Okay, intentionally blank. Kepler's laws. All planets move as having the sun as one of the foci. Wait, one of the other questions above us asked for estimate, didn't it? I think it was above here. I think it was the power one. Yeah, estimate. So this should be 0.8%. And then 99%. Okay. Bum ba bum. A radius vector joining any planet to the sun sweeps an area equal lengths of time. The squares of the period of revolution are directly proportional to that. Kepler's third law, which appears in the formula which can be derived for circular orbits from first principles. The centripetal force between it provided by that and S is the orbiting circumference and T the period. The system of any large celestial orbit and a satellite orbit around a baryon center. This represents the center of mass of the system. The barycenter of the Earth-Moon system, as shown in Figure 2, the system could be seen in the balance beam of the barycenter located where the fork would be placed to achieve equilibrium. The gravitational field strength due to the sun is identical for both, and therefore cancels out when calculating moments around barycenter. When the mass of the satellite represents a significant percentage of the system, the barycenter is either outside the body when this is outside either body. When this mass is significantly less, the barycenter is usually found within the more massive body, which appears to wobble. When the mass of the orbiting satellite is significant, barycenter can be assumed to be a mass of a larger body. Describe the relationship between the distance a planet is from the sun, representing orbiting speed, and its orbiting speed. The velocity. Use Kepler's second law. A radius vector joining it sweeps out equal areas in length of time. Orbiting speed decreases. Without justify this relationship to figure 1. Justify this relationship with reference to figure 1. To have an equal area for an elliptical orbit. So to have equal area swept when radius is bigger, larger for an elliptical orbit. distance traveled around the circumference must be less thus the velocity of the further object must be less if it travels less in the same time. Same time compared to a closer body elliptically orbiting the sun. Okay, using instructions given in an article, derive Kepler's third law from first principles, show each of the derivation must be matched to the equation in the formula data sheet, assuming the orbit is perfectly circular and the mass is insignificant compared to the mass of the body it is orbiting. The centripetal force between the planet and the sun is derived by Newton and S equals Vt, where the S is the orbiting circumference and T is the period. So we'll say that F of G equals F of C. We have G m1 and 2 over R squared. It's going to be mv squared over R. What the heck is this S equals Vt? The orbiting circumference, and T is the period. So V is equal to, so then V is equal to S on T. Is equal to 2 pi R on T. Is that what they want? I think that's what they want. Therefore, Gm m over R squared is going to be equal to m 4 pi squared R on T squared. M's cancel, so let's do Gm over R squared. It's going to be 4 pi squared R. I remember I forgot that squared of the pi many times. Over T squared. So then we have that T squared on R to the power of 3 is equal to 4 pi squared on Gm. Okay, using moments, estimate how far the barycenter of the Earth-Moon system is from the center of the Earth. Okay, when the mass is significantly less, the barycenter is usually found within the more massive body, which appears to wobble. The system can be seen as a balanced beam, with the barycenter located where the fulcrum will be placed to achieve equilibrium. So let's say moments around fulcrum so let's see, we have here, this is the Earth, we have the fulcrum here and then the Moon. Earth to the fulcrum, and the fulcrum to the center of the Moon. I think there's a mean Earth-Moon distance, is there? Yes, Earth-Moon distance is 3.84. times 10 to the power of 8 meters. Okay. So then sum of the anti-clockwise force equal to sum of the clockwise. Anti-clockwise equal to, so let's say this is R. And this one is 3.84 times 10 to the 8 minus R. Let's move this one down. It's equal to gravitational field strength, so G and then over R squared. It's 10 to the negative 11 times so the field strength times R times the mass of the Earth is 5.97 times 10 to the 24 over R, which is 3.982 times 10 to the 14 over R. And let's say the sum clockwise would be the gravitational field strength. So then G and R squared of 3.84 times 10 to the power of 8 minus R. Radius from here would be 3.84 times 10 to the negative 2 to the 8 minus R, because that's my radius from my moon to the fulcrum, times 3.84 times 10 to the negative 8 minus R. So then this would be 6.67 times 10 to the negative 11 times mass of the moon is 7.35 times 10 to the 22, 3.84 times 10 to the 8 minus R. So this is 4.902 times 10 to the 12 all over 3.84 times 10 to the 8 minus R. So now we have 3.82 3.982 times 10 14 over R is equal to 4.902 times 10 to the 12 over 3.8024 times 10 to the 8 minus R. So how am I going to solve this? Cross multiply, so 3.982 3.982 times 10 to the 14 times 3.84 times 10 to the 8 is 1.529 times 10 to the 23 minus 3.982 times 10 to the 14R is equal to 4.902 times 10 to the 12 r. So then I'll add that to the other side, so 1.529 times 10 to the 23, 4.902, 10 to the 12 plus 3.982 times 10 to the 14, 4.031 times 10 to the 14 radius. The radius is going to be, I feel like I did this wrong, because I'm going to get too big an answer. 3.79 times 10 2, 3, 4, 5, 6, 7, 8. It's 10 to the 8 meters. That is outside the radius of the Earth. So, 9 minutes. Oh yeah, I definitely did this wrong, because they're using that. Let's see. Two, and my mean Earth moon distance is that. Oh wait, no, this would be when the gravitational field strengths are equal, right? So let's say G of that R squared, and this can be G of the moon. Why was I looking at it like a torque question? Why was I looking at it like a torque question? So then I need these. Let's remove this. Squared, and this will be squared. So then I need that. Let's do 3.84 times 10 to the 8 minus r squared. It's going to equal 4.902 times 10 to the 12 r squared over 3.982 times 10 to the 14. So then let's square this. Let's square root everything actually. So I get 3.84 times 10 to the 8 minus r. It's going to equal the square root of 3.902 times 10 to the 12, 3.982 times 10 to the 14, 0.111 r. plus r. It says using moments though. Wait, that's why I was doing it. It said using moments. Okay, I think I'm just going to do this. Show that the ratio of the moon's orbiting velocity to that of the Earth is roughly AT. They orbit the barycenter. So then F velocity equals 2 pi r over t. Orbit the barycenter. Earth, moon, barycenter, Earth, moon. Pi r over t. Now time isn't constant, is it? T squared is equal to square root 4 pi squared r to the power of 3 gm. So then velocity is equal to 2 pi times 4.81 times 10 to the 6 all over for the Earth, and 4 pi squared by 6 all over 6.67 10 to the negative 11 times 5.97 10 to the 24 2 pi 4.81 10 to the power 6 6.67 times 5.97 times 10 to the 24 is 4.376 times 10 to the 10. And the velocity of the moon is going to equal, say, radius of moon. Three 0.84 times 10 to the power of 8. Minus 4.81 times 10 to the 6. So 3.79 meters. So the velocity of the moon is going to equal 2 pi times 3.79 10 to the 8 square root 4 pi squared times 3.79 times 10 to the power of 8 over 6.67 negative 11 times mass of the moon 7.35 times 10 to the 22 . Never mind. I got these questions wrong then. Well, it is what it is. This was tough. I have no idea how to do these questions. Because using moments, I couldn't get the right answer. Oh well. Yeah, I paused the timer. I'm not gonna do any more, so we'll get to marking this, I guess. It's not looking good for me, guys. Oh well. See ya. Okay, we're back. We got a tragic score of 85.7%. Wow. When I said it wasn't looking good for us, it really wasn't. We lost. I took a mark off from here because it needed a diagram for it, but it was actually hold on, pause. Okay, we're back. Yeah, I had to take a mark off because in the SCASA exam there was the image. You needed the image because it had an altercation. I finally got access to a Google Drive from someone on Discord that has the images of the WACE, of the actual WACE exam. So it has all the articles and stuff like that already there. I'm going to use that for 2023. But I'm still going to do the exam on this paper, on the actual official SCASA paper. But yeah, we lost 8 marks in section 1, 12 marks in problem solving, and 6 in comprehension. I also took off 4 for comprehension because again, there was information, but there wasn't a marking key. So I just took the 4 marks off. So let's get started. It's going to be a long marking session. Here, it is 0 because like the net EMF would be 0 or something. This is a complete circuit, sensitive ammeter. So like both sides of the someone said that like there will be 0 net EMF because it's a closed loop inside a magnetic field. EMF is induced in both sides of the coil but in opposite directions. So let's say that vertical. Vertical force down. Was this way. Positive charge will be that way. Yeah, I'm not sure. I'm not exactly sure why that's 0. EMF is induced in both sides of the coil but in opposite direction. So no net EMF. It's a closed loop inside a magnetic field. That direction movement is in. This way. Okay, we'll just continue. Here I took a marker from the total marking, and I didn't say that there will be the force will be perpendicular to the motion external field. You need to say that. Going on. I somehow got the wrong value here, but it's the correct value if you do divide by 16. So I don't know what I was dividing by to get 423. This was actually very smart. So if you come up with 20 electron volts of kinetic energy, then by the time you reach here, because you're decelerating going that way, because this is the positive one, if you go to the left, you're going to be left with only 10 electron volts over here, because of the electric field. So I didn't see that, but they said if you didn't assume that, you can get a maximum of 3 marks if the rest of it is correct. So yeah, 3 marks. Here was correct. You could have done this with the vertical as well, which I find is a bit odd because then it's not the center of the target. And then here they did it with the horizontal, how I did it like the second time. This is like my 3rd time doing it, where they said the 194 was within the 4 meter wide target. So yeah, but they also said you could do it the other way around, but they didn't show a marking key for it. So I just assumed that since I got an S over -30, that I'll get full marks for it. Going down, and here I lost 3 marks because I just didn't get any marks here. I needed to say to measure the length of the ruler, they determine the positions of the ends of the ruler at the same time. And then this is where I get confused. The second mark I'm already confused. Each thought the other's measurements were not made simultaneously. I'm not sure why they say that, because then they say at the same instant each measures. So I'm gonna have to ask around for that one, explain that. And then therefore they measure the other's rule is different to 1 meter, which I should have just said that for a mark or whatever. So moving on to section 2. They actually did this with not torque, but they did it with what do you call it? They just did f of y equals 0. Static equilibrium, I think that's what it's called. Static equilibrium, and then they got 464. But I thought, why would you not be able to do it with torque? It's a bit odd. So yeah, and then so I gave myself follow through marks for here, and then I gave myself, I lost 3 marks because first of all, I didn't need this cosine of 30 here because this is already my f of t, and then this cosine of 60 would be the horizontal component of that. And then over here, this also had to be 70. I think I wrote 70, crossed it out for 80, but it had to be 70 because anti-clockwise is actually this mass here, not the mass of the father. So yeah, but yeah, 450, if I did just cosine of 60, that would have been fine. But I got a mark because it's said to use 1 mark for halving the distance of the pillar, and then 1 mark for using that perpendicular distance. So 2 marks there, and then 2 marks here for the correct statement. Now you could have also said, talk about energy here, where the photon transfers energy to the electron, so then E equals hc over lambda. So when energy decreases, lambda will increase. I actually did quite well with these ones. Here I just forgot a times 3 because it's kilo electron volts, not just electron volts. I gave myself follow through marks. The actual answer would be 0.0114C. Yeah, I gave myself 5 marks there because I did the table. I didn't do this correctly because I didn't put -1 there. It was just meters. And this was good. And then I lost 2 marks here. I maybe could have been more specific and said 4 times steeper gradient. But I gave myself the marks anyway. And here I lost 2 because I needed to say that lambda was shorter. So range of values of y-axis would be greater. Because if I have this here, but this is a constant, then when I rearrange, lambda has to be shorter. So then this is bigger because you divide this over the side, I don't know. But yeah, lambda would be shorter. And when lambda is shorter, this would be greater. So then you have greater overall, what do you call it? That thingamabobby. Yeah, energy difference between the levels of helium are greater than for hydrogen. Okay, wait, I was understanding before, but now I'm not understanding as much anymore. Okay, so when this is like 2 squared, that's 4 times everything here. So this has to get bigger. I understand that. Then shows a selection, energy differences between. Oh wait, I don't think that's actually in this, but yeah. So yeah, lambda shorter, and then energy difference between bonds are bigger. I guess I could have just seen that from this diagram. I'm not sure. But 2 marks lost there. 6 marks. Good thing we came and checked for the sig figs when it said estimate. I lost a mark here because I needed to say changing magnetic fields induce eddy currents in the core. And here I lost a mark because I needed to say current carrying conductors have a magnetic field around it. And then I could have been more specific and saying, instead of just saying induced EMF in the second coil, I could have said allows current to flow in the transmission wires. Okay, this was good. Unfortunately, I don't know why I just made that V equals this. I'm not sure what I was thinking, but I needed to make it equal mv squared over r. I even wrote it over here. So if you did the follow through, you get 77.6. In the marking key, it also said that tan of theta could also equal, because this mv squared over r can also equal mg tan theta. So then tan of theta will also equal square root. Oh no, it would equal v squared over rg. And then you could have solved it that way. Velocity, radius, and gravity. But yeah, lots of different ways to do it. So down, I lost 3 marks there. This explanation was also good. There was 1 mark here that I was a bit iffy about giving myself, where you had to say tensions made of horizontal and vertical component. But since I quite clearly am talking about the horizontal and vertical component, I think I gave myself the mark there. And then here, I think we actually got full mark. Oh, this is the question I removed because there was just no marking key for this. But I think I got full marks for this thing above me. This was actually the massive number, 5.6 times 10 to the 8. I think it was 5.5 the marking key, but it's just a rounding error somewhere with decimal places. And here is where I choked. So here was all good. But then I got 2 marks here, because you got 1 for using these values for like the distances, and you got 1 for oh wait, no, I should only got 1 here, right? Hold on, let me check the marking key. Because I just realized what I was about to say. Yeah, no, because I didn't use moments around barycenter at all, because I changed at the last minute. So okay, I'll take a mark off there. And here, this was, I just didn't see this at the start, but this was actually constant because you move orbiting around the same barycenter, so the same center mass. Like how all of Jupiter's moons, the t squared r thing is all the same because it's the same center mass. And since we have a new barycenter for central mass, t is constant, so we can just do like this, which is the 2 pi r over t over the 2 pi r over t of the moon and the earth. You see that these t's are cancelled, the 2 pi's cancel, so all we're left with is just essentially the radius from the barycenter to either the moon or the earth, and they will be 78.8, which is roughly 80. So I got zero marks there. I believe uses t equals. Oh well, I did give what's there. So maybe I give myself 1 mark. Okay, just to make it easy for myself, I give myself 1 mark. Because it says one of the marks is to use t equals 2 pi over v, but this is just a rearranged version of that, so I think that's fine. And then, yeah. So I lost 1 mark here and I gained 1 mark here, so we'll stick with 2 marks, it's fine. But yikes, yeah, this exam wasn't, I did not perform very well in this exam, I'm not very happy with that at all. And my WACE is tomorrow. It's alright, we got the 2023 WACE to do, so let's get started. I think I'm gonna eat first though.